In this video, we're going to be going over lesson 1-4, where we will solve equations using square roots and cube roots. So that's what we're doing in this section. It's lesson 1-4. By the end of this lesson, I want you to be able to solve equations involving squares or cubes. And the standard that we're going over is listed here. It's 8AR 2-3. And we're going to jump right into the lesson. All right, so the essential question that we're trying to understand here and answer is how can we solve equations with squares and cubes? So example number 1, we have solving equations involving perfect cubes. And we have here Darius is restoring a tabletop. And he wants to finish the outside edges with a piece of decorative molding. What is the total length of molding that Darius will need? So we're looking here for the length of something, and that is important when we're solving these here. Our key words that we're going to look for is that the tabletop is a square. So that's letting us know that we're going to be using our square roots. And since we're looking for the length, we're going to limit this to just the positive root because length and distance cannot be negative. So the first thing they advise us to do here is to draw a diagram that represents the tabletop. So here we have a square, and they tell us that the area is 25 feet squared. That is our indicator that we're using a square root. And so the formula we use to find the area is the side squared. So once we find the side and you square it, that tells us what the area is. Or we can work backwards if we're given the area. That's what we are using here. So the formula is area equals side squared. We know that the area is 25. So 25 equals side squared. And then you have to do the inverse operation. So this is where we're going to be using our algebraic notation in order to be able to solve these equations. In order to find what that side is, we're going to square each side. So that's what's happening here. We're taking the square root of each side. And we know that the square root of 25 is going to be a positive and a negative 5. And the reasoning is here. We've talked about this in class. We know that both negative 5 squared will equal a positive 25, and also positive 5 squared will equal a positive 25. We will need 5 feet for each side, and we're going to use the positive in giving the answer because length is going to need to be positive. So let's try another one. So I want you to pause this, try it for yourself, and see if you can figure out how the notation goes. After you pause it, you'll see how I do it, and then we'll do some more practice problems together. All right, so we're given this square here, and they're asking us what is the side length of the square below. So since it's a square and it's meter squared, we know that we're going to have to find the square root of 100. So first thing you do is you want to plug in the 100 into the formula. That's the area. So here, where we have the A, in its place of the A, we're given that the area is 100, so we just write 100 here. Now, since we have 100 as the area equals side squared, in order to find the result, we want to take the square root of each side. So that's what we're doing in the next box. We're going to be taking the square root of 100 and the square root of the side squared. When we do that, then we're able to cancel out the squares and the square root, and so we're left with only S. S is then alone, and that's why the S is brought down here alone. And now we just take the square root of 100. We know that it is both the positive and the negative root of 100 is 10. And that tells us that each side of the square measures 10 meters. And we're only just going to put a positive 10 there. All right, this is similar to how you're going to be entering the answers when you start working on the Realize. So please take note of the way we're answering the questions now and put that in your notebook. Okay, so for example, number 2, we're solving equations with perfect cubes. So in this example, we have Kyle, who has a large cube shape, that's a key word, terrarium for his iguana. He wants to cover the opening with a square screen. So what are the dimensions for dimensions S for the screen? So since we're working with a cube, we're going to be working with the formula of the volume of a cube. And that formula to find the volume of the cube is the side cubed. So we're working with our perfect cubes. Again, we're going to plug in the volume that we're given, which is 27. And we're given that here in the picture. And then in order to solve it, we have to take the cubed root of each side. When we do that, we end up eliminating both the cubed root and the cube, and S remains alone on this side. We have isolated that variable. Then on the other side, we simply take the cubed root of 27, and that's where we get this 3 from. Keep in mind that the value of S is not going to be positive and negative 27. We will not see both positive and negative when we're talking about a cube root. Only one of the roots will apply. And in this case, it's positive 3. Because if I multiplied negative 3 times, as we're doing here, the answer would be negative 27. And that is not the volume. The volume is a positive 27. It's a measurement. Each side of the terrarium is 3 feet. So the dimensions of the screen are 3 feet by 3 feet. All right, let's take a look here. So here's a try it for you to try now. I'd like for you to pause the video, try to use this problem using the notations that we're using up here, where you're cubing both sides, and then we'll check to see if you're getting the same answers. All right, so in order to solve this x cubed equals negative 64, we're going to take the cubed root of both sides of the equations. Once you've taken the cubed root of both sides of the equations, then you will, these cancel out. The cubed root and the cube will cancel out, leaving x alone on that side of the equal sign. I will also bring down my equal sign, and on this side, I will simply take the cubed root of negative 64, which in this case will be negative 4. And we know that because if I take negative 4 times negative 4 times negative 4, I will get a negative 64. Remember that a negative multiplied by a negative gives me a positive. Still multiplying the other negative 4 that's left here. So this negative 4 times this positive equals a negative 64. Okay, so the final answer then is going to be x equals negative 4. All right, so now in example number 3, we're going to be solving equations involving imperfect squares. So imperfect squares and imperfect cubes. And there's a couple of different notations on here, so we'll practice plenty of problems so you can see the differences. So we'll start with this first one here where we're going to solve for x on letter A. And we have x squared equals 50. So we're going to take the square root of both sides. And since the square root of 50 is an irrational number, it's a non-perfect square, we simply are going to leave it is with using the symbol of the radical of the square root. And here we want to make sure that we include that the answer would be x would be equal to a positive and negative square root of 50. When you're working on these on Realize, it's going to ask you to give the answer as an exact answer. This is what it should look like when you give it as an exact answer. We're giving it exactly as the square root of 50. It says here that because 50 is not a perfect square, to write the solution using the square root symbol. And remember that when we have a square root, we have two possible solutions. We have both the positive and the negative, which is why we use the symbol positive and negative square root of 50. Let's take a look at example B now over here on this side. And we're looking at the cubed root of 37. So again, you will take and cube both sides. So that's why you see here that up here in the first initial example, x is just x cubed. And then we add the cubed root symbol to each side of the equation, which cancels them out. This is the inverse operation. You're doing the opposite. And so they cancel each other out. And all that's left there is just an x. X equals the cubed root of 37. Again, since this is a non-perfect cube, we're just going to leave our answer in this format as the cubed root, x equals the cubed root of 37. This is what's considered an exact answer. So when you're asked to give an exact answer, you're going to leave it with the square root or the cubed root symbol over the irrational number. Remember that when we're working with cubed roots, that we only have one possible solution. It's either positive or it's negative, but it will not be both. Okay, so here we have some tries. I'd like for you to try A and B using the notations, the algebraic notations, meaning that you're writing it using the algebra symbols on both of these. Pause this and come back and check to see if your answers are correct. Okay, so for A, we have a cubed root that we're working with. So A cubed equals 11. And so in order to solve that, I need to take the cubed root of each side of the equation. When I do that, I know that this cube and the cubed root, taking the cubed root of something, will cancel each other out, which means A is left alone on that side of the equation. That's how you get A by itself. Then you bring down the equal sign. And here, since this is a irrational number, I will leave my answer as the cubed root of 11. And since it's a cubed root, we only have the one solution. I don't need to add that positive and negative symbol. It's only one solution when it's a cubed root. Now for letter B here, we have a square root. So we have the letter C squared equals 27. Again, in order to solve this, I will have to take the square root of both sides. The square root and the square cancel each other out, leaving C alone on one side of the equal sign. Bring down my equal sign. And now this is a square root, so I have to remember that square roots are given both in a positive and negative answer, and it's the square root of 27. I'm not going to approximate it. I'm going to leave this as my final answer. So both of these are my final answers for the triads. All right, so just reviewing and recapping the key concept of what we're trying to learn with this lesson. Remember that when we're solving square roots, we can use the square roots to solve an equation, leaving it as the square root format, using the symbols of the square root, but we have to remember that square roots will give us both a positive and a negative answer. If you're measuring length, distance, something that's physical, Your answer then will be given in a positive response, but remember that the square roots will normally have a positive and a negative. You can give your answer with a comma like is shown here, or you can use the symbol that I like to use where we have the positive and negative square root of a for that example. Also, when we're working with cube roots, we want to make sure that when we're working with cube roots that we're cubing both sides of the equation. And remember, when you are using cube roots, that we only have one solution when we're working with cube roots. If you're following along in your book, I have gone over pages 34, 35, and now we're going to start practicing some of the problems on 36 and 37. So if you want to follow along, I'm going to jump around to different problems. Make sure that you're pausing. You try the problem first, and then you come back to the video for support and to see if you're doing things right or wrong. Write down any questions you have, and we can go over them together. All right, so take a look here at question number 2. Okay, so let's take a look here at question number 2, where it says Suri solved the equation x squared equals 49 and found that x equals 7. What error did Suri make? So please pause that, pause the video, see if you can answer that question, and then come back and check your result. Okay, so we see that Suri says that the x is going to be equal to 7, where she is partly right. Since we have x squared equals 49, we need to remember to take the square root of both sides. And so x squared and the square root of x will cancel each other out to leave x alone on that side. But we need to remember that since this is a square root, we're going to have both the positive and the negative root of 49, which is 7. So she just forgot to include the negative 7 in her answer. All right, so now we're going to try numbers 4 and then number 7. I'd like you to pause the video, try those two problems, and then come back and let's see if you got them correct. All right, so for number 4, we're being asked, why are the solutions for x squared equals 17 irrational? Well, they would be irrational because we have x squared, which would equal 17. And in order to find that, we would take the square root of each side. These cancel. And so x would be equal to the positive and negative square root of 17. And we know that the square root of 17 is an irrational number, so both of the answers would be irrational numbers. Both positive 17 and negative 7 square root of 17 are irrational numbers. If you haven't tried number 7 yet, please pause it and do that first. So here we have x cubed equals negative 115. This is a cubed root. So I'll ask you now, how many solutions should we have? Let's see if you can answer that. If you said 1, then that would be correct. So we have the cubed root of negative 115. We're going to take the cubed root of each side in order to solve it, which would isolate our variables. We would cancel out the cube root and x cubed, which leaves x alone on one side of the equal sign. We would bring down our equal sign, and since this is an irrational number and it doesn't simplify, we're going to leave it as an exact answer by writing it as the cubed root of negative 115. And that is our final solution. All right, so now I'd like for you to try 8, 9, 10, 11. We're going to do 12 and 13. So please make sure you're pausing in between each one. You try it first, and then come back to the video to check to see if you're getting this right. Once you know you're getting this right, you're ready to begin the practice problems on Realize that are similar to these. All right, so for the first one, we have z squared equals 1. So we should write in this box z, let me use a different, z squared, and then we're gonna, so we first you write them, both of the numbers, you write them under the square root radical, and that's going to cancel out the squaring, and so z is left alone on one side. Remember, when it's a square root, we have the positive and the negative root, and you want to say it's positive and negative 1 since it's a perfect square. It simplifies. So my solutions are 1 and negative 1. Okay, so now for number 9, please pause it if you haven't done so yet. Come back and check your solution. So for number 9, I should have a cubed here and the cubed root of 8. And we know since it's a cube, and in this case it's a perfect cube, a is going to be alone on one side, and taking the cube root of a, we'll get the answer of 2. Pause number 10. Try it and come back and check your answer. Okay, so our response, the response you should have here for number 10. All right, so you should have v equals positive and negative square root of 47. Remember, when it's a square root, you want to include both. And since this is an irrational number, if you're asked to enter it as an exact solution, you want to enter it as the square root. Because when we enter it as a decimal, we're approximating it. It's not exact. This would be an exact solution. All right, let's move on to number 9. Pause it and try it first. Okay, so for number 9, we know that we're working with a square root. And we're working with a square photo, and it says 9 inches squared is our measurement. So that's what we're working with, the square root. So we'll say that this photo, we'll just label it X. We don't know what it's worth. All right, so we're just going to label this X. We say X squared is equal to 9. So in order to solve it, you're going to find the square root of both sides. You cancel those out, and X is alone on one side, and it equals to the square root of 9, which is a perfect square of 3. But remember, we have to take both the positive and the negative root. And answering this in words, which you will have to do, you will say that each side of the photo is 3 inches long. Okay, because we know, even though this is the proper way to answer it using both the positive and the negative root, we're talking about a picture and you're measuring the length. So it's going to be 3 inches long, the positive. All right, let's move on to number 12. Pause the video. All right, so the solutions we should have for number 12, we should have y equals both positive and negative 89. Right, the square root of 9, the square root of 81 is both positive and negative 9. Number 13, pause the video and come back and check your answer. All right, and our answer here, we should have w equals negative 5. We know that when we have a cubed root, we just have one answer. All right, now I'm going to move over here to the side. So this is where you just want to take some notes in your notebook to help you prepare for some of the problems that you're going to see when you're working online. There will be questions that you'll be asked to actually approximate a square root or a cube root. So I'm going to show you how we do that. So here's an example. We might have g squared equals 32. Now, when you're working online, you will have to read the question. You'll be asked either to enter the answer to approximate it or estimate it, or you'll be asked to enter the answer as an exact answer. When you're asked to enter it in as an exact answer, you will do it like we did here, as with using the square root or the cubed root symbol, the radical. When you're asked to approximate it, you have to you can use a calculator to approximate it in lesson 1-4, but you need to enter it in a correct way. So still, you would have to take the square root of both sides of the equation. Remember, when it's a square root, that we need both the positive and the negative root. And you just put the square root of 32 into a calculator, and it'll tell you to approximate it. And so we're going to use 5 7/10 as our answer, and make sure that you're entering both the positive and the negative when you're doing this in the system on Savas Realized. Okay, so that's one example. Right. I'm going to give you another problem for you to try. All right, so try z squared equals 46. Please pause the video and use a calculator to estimate this, giving me an approximated value, not an exact value. All right, so to solve this problem, we know that we need to take the square root of both sides, and so those will cancel out here, and will leave us with z on this side. And now we're looking for an approximate value for the positive and negative value of the square root of 46. So if we're asked, which you will be asked, to approximate this, let's think about where that would be. So we know that the square root of 46 would be in between the perfect squares of 49 and 36, and it will be much closer to 49 than it is to 36. So we would say that it is approximately, z can be approximately close to 7. This is the way you would need to enter it. And so now let's find what that would be using a decimal to find the square root of 46. So we would say z equals, and we would put into a calculator the square root of 46. You put that into a calculator. And when you put that into a calculator, you would get z equals the positive and negative 6.8. or 6 8/10. Okay, so please keep in mind that there will be times on Savas Realized where it'll ask you to choose the one that it's the closest to, and you have to enter that as an approximate value. And it will also ask you to enter the decimal as an approximate value. There is 1 or 2 questions where it's going to ask you to enter it this way as a part 1 and part 2 question. Okay. All right, the last example I want to show you before you start working on Savas Realized is an example of a question that looks like this. They're going to ask you to explain why the cubed root of this fraction, negative 27 over 125, equals negative 3/5. So we have worked on these in class before. So we know that if I were to take the cubed root of each part of this fraction, so if I cubed this and I cubed this, I would end up getting the cube root of 27 is going to give me that 3. The cube root of 125 will give me that 5. And since the fraction is negative, the answer will also be negative. But when you have to answer this, the reason is the way you give the answer is because if I were to take this fraction and cube it, I would get negative 27 over 125. So you're going to enter your answer as negative 3/5 times negative 3/5 times negative 3/5. Now in Savas Realize, when you go to enter this answer, you're going to have to, in the box, you first put the negative sign, click the button to show a fraction, type in the 3, hit the down arrow, type in the 5, and hit the right arrow to go the next. And then there's a button for the times sign or the dot. And then you do the same thing again here. If you need any help with this while you're doing this in class, please ask me and I will show you how to enter it, enter the answer into Savas Realize. But the reason that this equals, that this cube root of negative 27 over 125 is negative 3/5 is because when you cube that fraction, you get that answer. I hope that makes sense. All right, so now I'd like for you to log on to Savas Realize and start working through all of the practice problems that are listed for 1-4. Remember that you're going to have 1-4 set 1 of practice problems, then 1-4 set 2, and then you will have to complete the 1-4 quiz in preparation to get us all. Then after that, we're going to be practicing and getting us ready for the topic 1 assessment. All right. Good luck.